Hello and welcome to RetroTech India. I'm your host, Naya, bringing to you yet another episode on the Java Beginners interview series. So, I guess all the videos on while loops, if you have watched till now, this one would be more or less a culmination of all the concepts in while loops that we have learned. The topic is actually quite interesting. It is to find whether a number is a special number or not. Now, let's get on the board and first understand what kind of number is termed as special. Then we will discuss as to what logic will be applying in order to check. So, the whiteboard on your screens here. So we have write a program to check whether a number is a Krishnamurthy number or a special number. So these numbers can be termed as anything, either Krishnamurthy or special number, right? Now, a Krishnamurthy number or a special number is a number whose sum of factorial of its digits is equals to the original number. And the example is given 145. So 145 has three digits, 145. If I take out the factorial of all, I should be able to get 145. So 1's factorial is 1, 4's factorial is 24, and 5's factorial is 120. If you sum it up, you will have 145. And that is why this number is termed to be a special number. So here the first concept that we will be looking is the factorial of the digit. So first of all, we'll find out the digit, each digit of a number. Then we'll calculate the factorial of that. And after that, we will calculate the sum of it. Okay, that's literally the logic. We know how to take out the digits, we know how to calculate the factorial, and we know how to take out the sum. So these are the combinations that we will be using, right? Now, in the last video, we have already discussed about how to calculate the factorial of a number. So if you haven't watched that video, please go ahead and check that video first. Also, it would be amazing if you can check the code for reverse numbers and the sum of all numbers or sum of n natural numbers to understand the concepts separately. Okay? If you have watched everything, then we'll go on the Eclipse board to do our code. So the last video was about factorial and the factorial code is right here. Okay, we will be utilizing this. That is the reason why I have not cleared it yet. So first of all, we need to take a number. Okay, let us go ahead and let us take a number. So int n is equals to 145. Let's take that. Okay, while n is greater than 0, we will say int last digit is equals to n mod 10. And because we will have to learn, ensure that this loops go further, so we'll go n is equals to n divided by 10. Now in the variable ld, we will have the last digit. So first time we will have 5, next time we will have 4, and last time we will have 1. Okay, so we want to take out a factorial of that as well. What we are going to do is, in order to calculate factorial, first of all, we will take while. So let's go ahead and take I is equals to 1. Oops. Int I is equals to 1. LD is already there, so we will be writing the condition I is less than equals to LD. Okay, that is the reason why I've taken 1. Then we want factorial, so for that we will say int f is equals to 1, and here we will say f is equals to f times I. And because we want to work this loop also further, we'll go I plus plus. So I will go up till whatever is the LD. LD has 5, let us say, so I will go up till 5 and it will do 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5, like that. Now this f will need to be then added. So what I'll do is, outside I will take int sum is equals to 0, and here we will say sum equals to sum plus whatever the factorial is. Okay, once that is sorted, we will have to check whether that is equal. For now, I just simply want to do one thing before I start checking. I want to print the sum. So let us go ahead and print the sum. And as you can see, the sum is 45, right? What if I print n though? What will I get? And if you have seen my previous videos, you will know what the answer is. So let's go ahead and run this. N is 0. Why is that? We know that here because we are running the while loop on the variable n itself. The outer while loop is on the variable n. N is going to be divided by 10 or at all times till the time it becomes 0. Okay. Therefore, we need yet another variable in which we can store the value of n. So we'll take n1 is equals to n. Okay. And here we will check. So I'll just simply remove these statements. I'm not removing it per se. I'm just simply commenting it, meaning these statements won't be executed. And here I will check if sum equals to n2, then system.out.println number, or we'll just say special number. Else not a special number. Okay, so these are all the logics that we have applied earlier. Oh, I'm so sorry, my variable was n1 not n2. For some reason I had written n2, that is why it was showing that there is an error, meaning there was a variable which I have used but not initialized. So now it should tell me that it is a special number. 145 is a special number. Let us say if I change this to 146 for instance, then it will say it is not a special number. Okay, so the logic was actually very simple, but there are two while loops. So the first time anyone will see this code might get a little confused. There is an inner while loop and there is an outer while loop. Okay, it's actually pretty easy if you know the breakups of the program here. For example, this part of the program where we are using the second while loop is simply to get the factorial of a number. The outside while loop is simply to get the last digit each time. So basically the process is we are getting the last digit and then from that last digit we are getting the factorial of that number and then eventually adding it. Right? So adding the factorials of the numbers together. And that is literally the logic of the code. Okay, so let us go ahead and check out the dry run so that we understand how the code is. I will come here, go to the whiteboard. Here we go. Let me just go ahead and do this a little bit. Yeah, this should be fine. So first of all, we'll start by saying that int n is equals to 146. Let us take 145 only. Just a second. Let us say, yeah, let us make this 145 itself, so as to not cause any confusion. Okay, so n is equals to 145. n1 also has the value of n, so it will also be 145. Next we have sum is equals to 0, so sum 0. Next, while n is greater than 0, so n is 125, the condition is true, it will go inside. It will do LD is equals to n mod 10. So LD is n 145 mod 10. So 5 will come here. And n is equals to n divided by 10. So the n will become 14. Next, I is equals to 1. So I is equals to 1. F is 1. I is 1. F is 1. And then there is another while loop. So in this while loop, what will happen is I and LD is there. So while I is less than equals to LD, meaning this loop will run till the time when I becomes 1, 2, 3, 4, 5, because LD is 5, and it will do 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So F at the end of the while loop will have 120, right? And I at the end will also be 6 actually. Okay, last but certainly not the least, after this while loop is over, I have not explained this try run of this while loop properly here. But if you watch my previous video where I have explained the factorial, you will understand exactly what happened and how did we end up getting the factorial of 5 as 120. Okay. Now sum is equals to sum plus f. So f is nothing but 120. Sum right now is 0. So 0 plus 120 is 120 only. Okay. So again, this is the end of the previous while, which is starting here. Again, it will go back and check. Is 14 less than 10? Sorry, 14 is greater than 10. N is right now 14. 14 greater than not 10. 0. Oh my God. Okay, let me read that again. So while n is greater than 0, meaning 14 is greater than 0. Right now n has 14 only. So it will take out the last digit. Last digit is going to be 4. 14 divided by 10 modulus, the remainder will be 4 only. And this will become 1 because of this statement. Then we will have again L, I and F will be 1, 1. And again we will calculate the factorial. The factorial of 4 will turn out to be 120. So after this entire while loop, again we will have not 20, 120. It will become 24 because factorial of 4 is 24. In the end, we will have sum is equals to sum plus f. Factorial is 24, right? So, I'm no, sorry, 24. Yeah. So sum has 120, factorial has 24. 120 plus 24 is 144. That is what we will get here. And lastly, this was 1. So again, it will go inside the loop. It will take out the last digit 1. It will take out the factorial of that and it will add that. So 144 plus 1 is 145. So that is why we are checking sum is equals to n1. Sum is 145, n1 is also 145. Therefore, they are special numbers. Okay. If you will understand the dry run easily, the rest of the code should be very, very easy for you. But I should also mention here that I did not explain the entire dry run. I did not explain the inner while loop, and the reason as to why I did not do that is because we have already done that in the previous code. I will be sure to put down the link of the factorial video on the description. But it would be great if you could watch that video first before you check this out. Okay. Other than that, if you like the video, hit that like button and subscribe. Have a great day ahead.